Bismillahirrahmanirrahim. Dear student, our today lecture is about some basic terminologies. These basic terminologies are really helpful when we deal about Gauss law. But before going to discuss these basic terminologies one by one, it is a humble request to you people to like the video, subscribe the channel and press the bell icon so that you may receive notification when I upload a new video lecture. So student, these basic terminologies are Gaussian surface, net charge, net electric flux and excess charge. We know about surface, but what mean by the Gaussian surface? We know about charge, but what mean by the net charge? We know about electric flux, but what mean by the net electric flux and what mean by the excess charge or excess charges. So to answer all these questions, let's start it and keep in mind Gaussian surface can be defined as any closed imaginary surface is called a Gaussian surface. A Gaussian surface like this. But the necessary condition for the Gaussian surface is it must be closed. Now what mean by the net charge? Consider this Gaussian surface here. Suppose there are some positive and negative charges enclosed by that Gaussian surface, or some positive and negative charges are within this Gaussian surface like this and this represent positive charge, this is positive charge, this is positive charge, this is negative and this is negative. So what will be the magnitude of the net charge enclosed by that Gaussian surface? So to determine the magnitude of the net charge, we have to simply add all these charges. So Q net is equal to adding all of these charges plus Q plus Q plus Q minus Q and minus Q. So the net charge is equal to plus 3Q minus 2Q. So Q net is equal to plus Q. So the net charge enclosed by this Gaussian surface having magnitude plus Q. Now student, what mean by the net electric flux? Again considering this Gaussian surface, but now this time we have two point charges, one is positive and the other one is negative. These two charges will attract each other and will create an electric field or develop an electric field. The electric field are usually represented by electric field lines which are pointing from the positive toward the negative charge like this and this. But student, here are many or infinite number of electric field lines, but we will consider just few of them to understand the concept behind the net electric flux. So let's say here is an electric field line which leaving this closed surface and entering again to the closed surface. At this position the electric field line leaving the closed surface, and on this position it again entering to the closed surface. Here is an electric field line which leaving the closed surface and entering again to the closed surface. So now there are two electric field line which are leaving the closed surface, and on this side two electric field line again entering to the closed surface. So the number of electric field line leaving the closed surface are equal to the number of electric field line entering to the closed surface. So it means that the net flux through this closed surface is equal to 0. So in this case the net flux is equal to 0. And we have another case when no electric field line passing through closed surface. So in that case electric flux will be equal to 0 as well. Now we are going to discuss some another cases in which one of the charge either positive or negative will have double magnitude. For example, consider again Gaussian surface. This Gaussian surface enclosing 2 point charges plus and minus. But here I want to bold this positive charge or to highlight this positive charge. It will indicate plus 2q or greater magnitude of charge. So this will now represent 2q or double of the magnitude as we have used here. So now what will happen? Keep in mind student, if I have an electric charge, this electric charge producing an electric field which are represented by electric field lines. Suppose this charge produce 4 electric field lines. If I double the magnitude of this charge, so what will happen to the electric field lines? The electric field lines will also double. So if I double the magnitude of the electric charge, so the electric field line will be look like here. One, two, three, four, five, six, 7 and 8. So now in this case again electric field developed by these two charges are represented by electric field lines which are like this and this. But keep in mind again we have some electric field line leaving the closed surface and entering again to the closed surface. Here is another electric field line leaving the closed surface and entering to the closed surface again. But here the magnitude of the charge is double, so we will have greater or more electric field lines. But keep in mind these electric field line will leaving the surface but will not enter again to the closed surface. So in this case more electric field line leaving closed surface and less amount of electric field line entering to the closed surface, or the number of electric field line leaving the surface is greater than the number of electric field line entering to the surface. So in this case the magnitude of the electric flux can be considered, the net electric flux magnitude can be considered positive. Okay, now consider another case where the magnitude of the negative charge will be doubled. So what will happen? What will be the magnitude of the net electric flux? Again consider a Gaussian surface. It enclosing positive and negative charges, but in this time the magnitude of the negative charges is greater than as we have used before, like this. Keep in mind a negative charge produce electric field inward toward the center. So there are four lines. If I double the magnitude of this negative charge, so the number of field line will also double. It will become now 8 numbers of electric field line. 1 2 3 4 5 6 7 8. So here the electric field developed by these two charges will be represented by electric field line like this and this, and again we have some electric field line leaving this surface and entering to the closed surface like this. This is another electric field line leaving the closed surface and entering to the closed surface again. But here we have some electric field line which are entering to the closed surface, but these electric field line will never leave the closed surface. So here the number of electric field line entering to the surface are greater than the number of electric field line leaving the surface. So in this case the net flux can be considered negative. Net flux can be considered in this case negative. So this was the concept behind the net electric flux. Now the last one is excess charge. So what is excess charge or excess charges? Student, consider a conductor like this. Now in normal situation we have many atoms within the conductor like this. An atom, we have nucleus where neutron and proton are there. Here neutron and proton, and again in this atom we have neutron and proton. Now we have some electron or free charges as well. But be attentive, if I insert a positive charge in this conductor by some means, so what will happen? Let consider a portion of this conductor. If I insert by some mean a positive charge, so there must be some positive charges which are distributed over different positions. But now when I insert the positive charge, so there will be a strict repulsive forces started between these two positive charge, or these two positive charge, or these two positive charge. So these charges will be no more here. These charges will be repelled from each other and will start motion toward the surface of the conductor. So now the position of the charges will be here, 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 here and here. So all the charges are now reside over the surface. Now if I insert by some mean a negative charge within the conductor, so what will happen? Consider this is another portion of the conductor. If I insert a negative charge, so there must be some intrinsic negative charges as well in the conductor. So again there will be repulsive forces between the negative charges. So the charges will start moving toward the surface and charges will reside over the surface and will change his positions. So now how we will define the excess charge? So keep in mind student, those charges which resides over the surface, over the surface of a conductor are called excess charges. Excess charge, very simple. But before the insertion of this positive or negative charge, we have normal conductor and we have normal atoms, or we have neutral atoms. So when we insert the positive and negative charges, so there are repulsive forces between the positive or negative charges. So the negative or the positive charges will start motion toward the surface of the conductor, and those charges which reside over the surface of the conductor or which lies over the surface of the conductor are called excess charges. So this is the end of the lecture, and next lecture inshallah we are going to discuss Gauss law, and then we will discuss after the Gauss law its applications, and then we will discuss about electrical potential.